right, thank you. So good afternoon, everyone, and you're welcome to the very first class. It's more like an introductory class, and it's gonna be an introductory session where I get to speak to and more like introduce us to the concept of mobile development, and from there, probably the next class we're gonna do more of some things that are practical. But for this class, it's more of an introduction, and I'm just going to be going through the world of mobile development, the nitty-gritty of mobile development, and also the different areas you can focus your attention on, the different areas you can find relevance, the different areas you can, delve into in the scope of mobile development. So my name is Oluwasegun, and I'm currently a software engineer, mobile development as well, with Stampic IBTC. I work with a mutual fund, that's the investment section of the bank. And yeah, I've been a software engineer for give or take 3 or 4 years. And I've had experience as well with web development, both front end and back end, using JavaScript and TypeScript. And yeah, that's a brief about me. I love reading, I love playing football, I love video games as well. What else? Yeah, I love traveling. Yeah, I actually love traveling. I would love if I can travel the whole world. Yeah, I look forward to that. So that's few things about me. And I came into software engineer basically because I was trying to find an area where, I mean, a workspace or a place where I get to learn. Like I get to learn every day. I get to, it's more like there is no end to learning. That's something that I love about software engineering. There's no end to learning. You keep learning every day. In fact, one of my uh, trainers then, when I did some things boot camp, he told me something that stayed with me over years, and it's the fact that software engineers are paid to learn. And please, you have to hold that in your hands as well, so you navigate this part of software engineering, be it mobile development, be it front end, back end. It doesn't matter the stack you find yourself. One thing is very important is the fact that you keep learning, and you have to keep learning. That's one thing. You have to keep learning, like every day, all the time. We learn new way of doing things, new way of developing things. How do you solve this bug? You've come across this bug before. You have to learn it in such a way that when you come across it again, you are able to fix it within a short period of time. So that's just a takeaway for the whole thing about software engineering. However, going into mobile development, I will just take a few minutes to talk about mobile development general. Then I'll talk about the different stacks. Then probably the next time we're having or the next meeting, I'll be able to go in depth into each of those stacks and introduce you to the different ones we have. So for mobile development, the whole thing about mobile development is about developing mobile apps for different platforms, usually for mobile, for the mobile environment or the mobile landscape. You have two different OS, or at least two different known OS. That's the Android OS as well as the iOS. That's from Apple. You have the Android OS and iOS. And they are two different OS, right? They are two different. As far as they run on mobile, they are two different OS. And I believe, right, that they are all forks of Linux, right? They are forks of Linux. And I know Android is fork of Linux. iOS over time, be it Mac or they are all forks of Linux, but they are not forks like the way Red Hat, Ubuntu, OpenSUSE. Please confirm I'm still in this meeting. Sorry, please, can you see me? Please confirm you can see me. I had a
Yeah,
whiteboard pop up some minutes ago. Okay,
I
so
can hear you.
all right, cool. So they are not forks like the way the open source and the likes are, but they are one way or the other. They have Linux in their base. So, but like I said, the whole mobile landscape is basically those two OS, the Android OS and the iOS. So when you develop mobile application, those two platforms comes to mind. That is either you are developing for iOS or you are developing for Android OS. Excuse me, 1 minute, please. So those are the two things as far as mobile application development is concerned. Basically, like if you're doing web, to a greater extent, what comes to mind is you're developing something that your client, the browser, can access, right? So when you develop mobile application, you are developing something that can work on Android or iOS. I don't know if that part is clear. Is it clear? So
Yes, yes.
those two operating system comes to mind. So what that means is when you want to develop for Android, when you want to develop application, since those two operating system comes to mind, there's a need to understand the operating systems, those two operating systems. But that doesn't mean that you have the nitty gritty or the ins and outs of Android and the ins and out of iOS. No, that doesn't mean. But at least you have an understanding of how they work. You have an understanding of how an Android system, for instance, an Android application, you have an understanding of how it starts, how it's when you minimize the application, what happens? When you want to resume the application after minimizing, what happens? So a deep or a good understanding of the Android operating system is actually very important when you're developing mobile application. Or the iOS, when you start the application, when the application comes on board, those processes, because the reason is because you want to do some things. There are times that you want to do some things in the background prior to when your application launches. So you need to understand those stages of application launches. For instance, let me give an instance. When you start an application in Android, the first thing is the activity starts. Then the activity resume. There's an on resume, there's an on start, there's an on resume, there's an on end, there's an on stop. Those are different levels of applications. So you want to have an understanding of this level, these stages of an application, so that when you want to carry out processes or you want to pass data, you want to stop processes, you want to take advantages of a point, you know at what point am I taking advantage of this? The same thing goes for iOS. So the first thing most times when you want to go to Android or you want to go into mobile application development is that you should understand the underlying operating system you are developing for. That's the first course of action. Sorry, I will not be sharing a slide this time. I will be the next time we come on like this. I'll be sharing a slide properly and be speaking from the slide directly. But today, indulge me or permit me to speak from my heart and to speak from my experience as a mobile application developer. Is that fine?
Yeah, sure. Sure.
All right, cool. So thank you.
No problem, sir.
So now back to the conversation. One, have an understanding of the different operating systems your application will be launched on and your application will be working on. Now, having understood that, the next thing is how do I want to develop? Am I developing natively or am I developing using something that is not native? Now, when I say natively, I explain what that means. Now, to develop mobile application for these two operating systems, there are three ways actually, or better still, let me say two ways. The first way is you are developing on a native platform or a native tool that these distinct operating systems are known of or known to. Now, for Android operating system, if you're that's the Android operating system, there is a part where you develop natively. For the iOS operating system, you have some things as well to develop natively. Then in the center or in the middle of these two, you have the cross-platform or hybrid mode of development. And that's where the likes of React Native and Flutter shines. Then you have a multi-platform development. That's where something like KMP, that's Kotlin multipurpose, multi-platform too. That's where it shines. Now, coming back to Android native development, when you want to develop application that is native to Android, and what this means is that any application you write will only work on Android. That's a native application. It will not work somewhere else. It will not work in iOS. It will work for Android and in Android alone. Exactly, that's a native development. If you develop natively for iOS, any application you have developed or you have developed will work for iOS platform alone. That application cannot be bundled to work on Android. Then for the cross-platform, what that means is you have a bridge here in cross-platform. There's a bridge. Now, what's the bridge? Whatsoever you develop can work on either Android or iOS. That's a cross-platform mode of development. Whatsoever product you are coming with can be trans-compiled or compiled to work in Android or on Android platform, or it can work on iOS platform. That's a cross-platform application. The next thing you have is the Kotlin multipurpose tool. And what this means is that you have an application that can work is multi-platform. That means it can work on any platform, be it the web, be it desktop, be it iOS, be it Android, and any other platform you have. That's a Kotlin multipurpose development or multipurpose tool. I don't know if what I've explained thus far is clear.
Yes, yes, it is. But I have a question. I don't know if I can ask now. I should relate to
I'll
later.
entertain your question. You can just pen down your question.
All
So
right.
I'll just give room for questions once I've been able to direct, like, put my thoughts and conversation to a conclusive part. Is that clear? Is that fine? You can just note your questions. I'll take them afterward. So now, for each of these platforms, each of them have their own something about programming generally. I don't know how we have different levels for individuals on the call. You have people that may be beginners, you have people that may be intermediate in their career, you have people that may be senior level. Yeah. But this is it. For development, for software engineering, it's just like the way you tend to speak to everybody. You speak to different persons, right? When you want to speak to somebody that is able and doesn't understand English, doesn't understand Yoruba, you speak Igbo to the person. You want to speak to somebody that is Yoruba, you speak Yoruba to the person. You want to speak to an Englishman, you don't speak Indian, you speak Indian to a person. The same thing goes for programming, the things in programming as well. Anything you want to, like, for different things you want to do, you have different languages. When you go to the game development, you have a language that you can use in game development. When you come to data, you have a language that you can use in data. When it comes to engineering, you have a language that you can use in software engineering. So each of these data or data portion, each of them, they have their own, each of these courses, game development, they are different endeavor, different lines, back-end engineering, front-end engineering, name it. All of them, for each of these, you have a language that you use to communicate. to them, because basically what you're doing with languages is you are writing with these programming languages, you're writing code, your thoughts, your plans, everything. You're writing it in style, you're writing in something, you're writing in a language that is readable by man. That's the way you're writing. Now, computer doesn't read those language, they are high level for him. Now, how will computer read this language? Once immediately your sister saw me, and then oh, sorry, can you hear me? Can you hear me?
Yes, sir.
Yes.
Okay.
Yes.
Yes, we can hear you.
So, sorry about that part, please. So, for each of these endeavor that you want to do, each of them, they have a language that is unique to them. When you come to the game development, most times you tend to see C# shine in game development. When you come to probably you're doing blockchain, you see Solidity. Do you get? So for each of these, you have different languages that are actually used to communicate them. The same thing goes for when you come to native Android development. The language you use to communicate native Android development is Kotlin. Do you get? That's the language that you use. When it comes to native iOS development, the language you're using to communicate there is Swift. That's the language. When it comes to cross-platform development, if you're working with Flutter in cross-platform development, the language you're using to communicate is Dart. When it comes to React Native in cross-platform development, the language you're using to communicate is JavaScript or TypeScript. When it comes to KPM, that's Kotlin multi-platform development. It's actually, I think it's KPM. It's actually Kotlin multi-platform. The language you're using to communicate is Kotlin. So for a mobile engineer, it depends on what you want to. If you're going to native Android development, then you should have it at the back of my mind that what I'm learning is I'm learning Kotlin as a language. When you're going to Swift, when you're going to native iOS development, because those are different branches under mobile development. When you go to Kotlin, when you go to when you go to native iOS development, what you're using is you're using Swift for native iOS. For React Native, you're using TypeScript, right? Or JavaScript. For Flutter, you're using that. For Kotlin multi-platform, you're using Kotlin. Then there are other parts. There are still some other parts I've not spoken about. You have the likes of capacitors, Xamarin, but I'm choosing to move away from those parts so I can speak on things that are relevant to the age. There are still complaints that use Xamarin, right? But it's not as common as complaints that use Kotlin. It's not as common as complaints that uses React Native, that uses Flutter. If you gather 10 mobile applications, trust me, probably you'll find like 1 or 2 written with Xamarin if you're finding any in this current age. So to wrap the first level of communication up, or to wrap the first level of thought up, I'll just summarize on this part with 3 languages seems to be very important when it comes to, because I'm speaking language now because that is the foundation. You must learn the language first. When you understand the language is more like the ABCs. When you understand the language, you understand things in the language, you understand the way things are used in the language. Having understanding of those will actually help you to write codes. For instance, you don't understand ABC, you cannot speak words. But when you understand ABC, you can speak words, you can write words. You get? So basically, to nail it, 3 languages are very important. 1, Kotlin. 2, Swift. 3, 4 languages now. 3, JavaScript or TypeScript, then 4 Dart. And these languages have their own framework. For Android, most times what you're developing with is you're developing with Android Studio and some other things in Kotlin, basically concept in Kotlin and the likes, libraries and the likes. For native iOS, you're developing with Xcode. And that's when you'll be bringing in some other things, but basically that's what you're developing with. For React Native, you're developing with for TypeScript, you're you're developing with the framework called React Native. And you most times be working with VS Code. For Flutter, for that, you're developing with Flutter, and you'll be using some other related framework and the likes. So I'm going to just give a pause here. I'm going to pause here for a while. Accommodate your questions, respond to them, then we'll see how to wrap the first level of introduction up. So if you have any other question, if you have a question based off what I've spoken thus far, you can just raise your hand and we address those questions. I think somebody said he had a question earlier, so you can just raise your hand. Once you raise your hand, Adewale, excuse me, please, you can just take note of those that raise their hand, then you allocate a number to them to ask their question, and from there we can proceed again. Okay, Adewale, please, you can meet whosoever have a question. You can attach your number. If you have more than one, just give them a number, then you can then take it from there. Adebisi, please, you can, I think you have 3 hands raised.
Yusuf can speak, he's unmuted. I've unmuted of them.
All right, okay. Thank you. Thanks, Oluwasegun. So my question is, when you were speaking of the React and all of that, React itself, is it a programming language?
Okay. Sorry, please, I'll just take the questions one after the other. Once you give the question, I'll respond to it, and then the next person can ask the question. So, would that be your question?
No, that's not all. So and then again, you mentioned like a native language for each of the different OSs, whether it's Android or iOS. So does it mean when you write a code, like the language that you use to write maybe a native Android, for instance, does it mean you can use the same language to write your whole same code for your same app for the iOS? So does it always work for only one native? I don't know if that's the right word. Okay. And forgotten the third question. Okay, I think that will be all. If I remember the last one, I will drop it for you.
All right, no problem.
So, sorry, the last one. The framework that you mentioned, what does it really mean? Is it like a template, or what's the meaning?
Okay.
Sorry for the elementary question. I'm basically like...
No, it's fine. That's one of the reasons we have this class. Thank you. It's fine. Okay, so let me start with React. Although what I mentioned was React Native, but it's fine to talk about React. So for React is actually a framework it's not a framework, it's a library for web. It's not for mobile, it's for web. Do you get that? But for mobile, what we have is React Native. So I think I'll be answering the question of framework here as well. So for excuse me, the language for React Native, the language to use to write is TypeScript. The framework, I will explain what framework is. Now, the way framework works is, I want to use something in reality to actually explain what framework does. So, framework is almost like, excuse me, I'm trying to pitch something in reality to use that you can easily work with. It's almost like, instead of you going to buy a full cow, kill it yourself, slaughter it, and do everything, you get. Instead of doing that, you go to the abattoir, then you buy the cow that you need, and you prepare it, the part of the cow, the size of cow that you need. Then you prepare it as you want. But take note, you didn't buy the cow. You just took what you need and you prepare it as well. So the way framework works is that From framework, you can bootstrap a project. You can get a template of a project, so to say. Then you begin to add what you want to it. So basically, what this framework gives you, be it framework or library, I'm careful to use the two words, because something like React is not a framework. React is a library. But by the time you bring some other things into it, you bring the router, you bring the React DOM, you bring all of those to it. By the time you add it, then React becomes a framework. But usually what a framework will do is the framework will give you a structure of a code, the whole thing you need for this app to work. Then you begin to structure it to fit what you want to do. I don't know if that's clear. So more like when you create a project, say for instance, you want to create a shopping project, you want to create a shopping app. With a framework, by the time you run a command or so, a framework will give you a sample project. It will give you a sample project. And you begin to add libraries. You begin to probably you need a library to get date. You add that library. Probably you need a library, another library. And when I say library now, what library means is just packages that will help you to do things. I guess. So I'll give an instance. Say for instance, a person buys a land that is already built. He has a building there on that land. So but the building doesn't fit. The person doesn't like the way the building is. So it's a two-way thing. It's either the person pulls down the whole building, or in some cases, the person will begin to modify the building to fit what you will begin to add a part to it, remove another part, add a part to it, remove another part. So that's the way framework and all these packages work. So packages are more like the part, they are more like add-ons, things we add. Libraries, things that are already written by somebody else, you add them to your project so I can make use of those functionalities there. So that's the way packages work and all the framework works. So they are like tools that give you the opportunity to, you don't need to write some things by yourself. They are already made available. The only thing is that you're making it to fit your need. That's the way framework works. Or library, as the case may be, it depends. It depends on the use case. So now back to the whole thing about native. When you write an application on the native side, it will only compile on that native environment. It will not compile on another environment. So if you write an application with Android, with Kotlin on Android, when you're compiling your code, take notes. This is it. When you compile your code, there is something called compilation, and you make a build out of what you have made. Because the way it is for Android, the way Android works is the installable. If you take note, let me give you an instance. If you've used say for instance, you're using a Windows laptop. If you're using a Windows laptop, when you want to download an application online, you notice that the application is always .exe, that's executables. .exe. Probably you download Chrome. It will be chrome.exe. That means that exe you cannot install it on a Mac laptop. What you can install on a Mac laptop is .dmg. So when you build applications for Android, native Android, what you have is .apk or .aab. And .apk, and a file that ends with .apk, you cannot install it on Mac, on iOS. What you can install on iOS is .ipa. So if you're building an application on native Android, when you compile it and you make a build out of it, what you will get is .apk or .aab. And you cannot install any of those two on an iOS phone. The same thing goes for iOS. When you compile your code and you make it a build that can be installed on the phone, what you have is .ipa, and you cannot install .ipa on an Android phone. Now, where's the balance? The balance is the cross-platform. When you compile in cross-platform and you make a build, you can either build to be iOS or you build to be Android. So, and cross-platform is more like the bridge between native, the bridge that can be native iOS or it can be native Android. So I don't know if I've answered your questions, or is there any part of it not clear?
Yes, it is clear. What I understand the framework well. I'm very, very clear on that now. So, but the compiling and making a build out of it, I don't know. I'm asking that if like the language, for instance, that you used
Okay,
in
if you
writing,
use Kotlin to write a code, can you compile? Can you work on iOS, right?
yes, for instance,
Okay.
yes.
Okay. Now, there's a way it can work, and that's where Kotlin multi-platform comes in. If you write it in Kotlin multi-platform, it will work on Android, iOS, and work on the web. But if you are having your code, you start developing with Android Studio, and when you were creating your project, you said it should be an Android app, and to a greater extent, that code will only compile down to something Android for you. But if you're writing Kotlin multi-platform with Kotlin, it will work. But the way you can write iOS, you can write Swift with, you can write Swift that will compile for every platform, although they are still exploiting that. However, to date, one thing that has been perfected is that when you write Kotlin for mobile application, in most cases than not, you are writing for Android alone and you're not writing for iOS. I don't know if that's clear.
Yes, it is. Thank you.
All right, thank you. So the next set of questions, next person can answer, can raise this our question. I think I have two other hands raised. You can be unmuted so they can ask their question. Okay. If I understand where that means, there are no other question, right? Does that means there are no other questions? I can continue from there, and you can, before the meeting, I mean, this first section of the meeting ends. All right, so basically, right now, I'll just go through the pros and cons, and then I'll more like make a campaign for cross-platform mobile development. Yeah, more like make a campaign for it. From there, I'll be sharing this slide afterward in the next session on cross-platform mobile development. What I will be speaking on will be basically on that. But for today, I will speak on Kotlin and native under development. Then my next presentation will be basically on cross-platform mobile development. And before I do that, I'll make a case for it. Then I will go ahead and speak on this. Now, for native Android development, And that's a case where you're developing mobile application that is native to Android app, to Android OS alone. And mobile applications that are developing cases like that, they only work, they only work on the mobile, they only work on Android and nothing else, just Android alone. They don't work on any other platform. So, say for instance, and I think if I can recall very well, I think GT Bank, they developed their mobile app natively. I think. Like I think if I can recall very well, Sterling doesn't write native. Sterling writes React Native. I think Flutter Web uses React Native. I think Paystack uses, because they have a library for React Native, but not very functional. So I think, yeah, Junior uses React. Well, EcoBank uses React Native, and they have some parts native and Android as well. So now, for native Android, I'll just walk through the path. The first thing for native Android is, one, to learn the language you'll be using to write the code. That's the first course of action. Learn the language. For learning the language, please permit me, the next time I'm speaking, I may be more direct on how to go, and I'll be sharing a slide proper. But for today, I actually want an heart-to-heart conversation. And I was expecting that probably I'll have much of questions to attend to on people that are thinking of how to go about mobile development. So back to native Android development. The first thing is to learn the language. Learn Kotlin. You have to learn Kotlin. And Kotlin is actually a language that is because Android development used to be Java first. It used to be Java. It was Java that was used for Android development. But that, I think between 2020 or so, 2020 and 2020, if I'm right. But maybe I may be wrong actually with that date. Google, because Google is behind Android. It's Google that owns Android, while Apple owns iOS. Google, in collaboration with IntelliJ, made an announcement that going forward, Android will be Kotlin first. And what that means is that they reckon with Android apps that are written with Kotlin. So Android is going to be Kotlin first. Why? Why it's going to be Java second, right? So mostly what happened was that modern application, because since they said the owner of the OS decided that this is the language you want to use. So modern application began to shift towards Kotlin. For modern application, basically, they began to write the applications using Kotlin. It was really great because Kotlin is actually a language that took learnings from different languages and past. One thing about modern languages is that they take learning from the different languages of the past, then they try as much as possible to build on their cons. The downside of these old languages, build on that, use the downside to actually more like make a better language, so to say. So Kotlin is one object-oriented language, and it allows functional programming as well. It has non-safety. I'll explain it of what I'm saying. It has non-safety. It also it's actually multi-paradigm, and also it's an interpreted. I think it's a compiled language. Yeah. I'm trying to recall. Well, I'll do justice to that afterward. And Kotlin is easy to write, easy to read, and it's almost like English. Yeah, you see a lot of English when you're writing Kotlin. Now, what do I mean by object-oriented? This is it. Kotlin can, and you write, when you code in Kotlin, you're coding like you are writing, that's the object-oriented part of it. You're writing your codes as objects that can do things and that has things. What does that mean? Take for instance, maybe a cat is an object. Let's say a cat is an object. A cat has a name. There's a name people give their cat. The cat can breathe. The cat can give birth. The cat can run. The same thing goes for programming languages. You have, say for instance, you are building a class, you have something, an object you could take. Let me give an instance. A user in the bank, we could say a user of a bank is an object. The user. Now, if you own a bank account, there are things that you will know. One, you have a balance. Two, you have a name. Three, you have an account number. Four, you have some details with the bank. So all these details, one after the other, they are fields for you. They are things that you have. Then what can you do with the bank? You can withdraw, you can deposit, you can make international transaction. All these are really characteristics of that bank account. The bank account could be an object, and every bank account is similar. It's just the money that is inside, the value inside it, that is different. Everybody that has a bank account, you have a name. Everybody have similar details. So instead of trying to create multiple, no, you create a class that carries everything about an object. That's a class. It's more like the blueprint of a person, just like the blueprint is the blueprint of that person, of that account. So you cannot make everybody is from that blueprint that instances of different accounts are made. You have an account, yes. You have an account, yes. You have an account, yes. Are the accounts similar? Yes. Every account is similar. It's just the monetary value that is just different. Am I right? Every account has account number. Every account has transaction. Every account has account name. Every account has the day you were created. Every account has a batch. You get, every account has a nationality. So now, when you create that look alike of all accounts is the blueprint of an account. And that blueprint is the class. So when you code in that form, what you're doing is called an object-oriented programming. Your code is similar. The things you are dealing with, the things you are mutating, the things you are changing in your code, they have the shape of an object. The things you are making to do things in your code, they have the shape of an object. That's an object-oriented programming. I don't know if anybody understand. I can go through it over again to just give context to it. Do you understand?
I think it's
Sorry,
clear.
I think that's something. You said?
I said I'm clear.
Okay, cool. So that's the first part. Second part is that Kotlin is easy to write. Now, when you come to Kotlin, excuse me, please. When I say Kotlin is easy to write, actually, some persons may be like, oh, is there a programming language that is easy to write? Yes and no. When you start coding, most times programming languages can be challenging and the likes. But for Kotlin, when you're writing Kotlin, for instance, you have the let, you have the const, you have the function, when you write Kotlin, it's almost like you're writing. I wish I could write Kotlin, but I can't. So probably the next class, I'll just write a few things. But the take home here is that when you write Kotlin, it's almost like you are writing English. That's the way Kotlin works. It's almost like you're writing English because you see the kind of things around let, the things like for this in this, do this to this in this. It's actually easy to write and it feels like you're writing languages. I don't know if you get this. Does everybody understand that?
Yes, I do.
Yes, sir.
Okay.
Yes, sir.
Excuse me, please. So that's why I said Kotlin is easy to write. It's almost like you're writing language. The fact is not like because a good number of times people get scared when they come into programming. Oh, I have to learn this and that. But it's almost like you're writing. You say something like around in this, apply this. As if for you like it's pretty explanatory in most cases than not. That's the next thing. Then excuse me, I'm trying to recall things I said around. Then you have the no check of Kotlin, the non-safety part of Kotlin. And what do I mean by that? When you write in Kotlin, Kotlin basically will not allow your program to crash in development. I mean at runtime, because it checks non-safety is actually something that is very important in program. And what that, in a case like that, what's happening is that probably you have a variable that you've not attached that doesn't have a value. So in a case like that, it's none. So if you have a variable like that in your code, what's going to happen is that when your code rather, sorry, tries to reach or access that variable and make it do something that you want to do, the variable doesn't have a value. So in a case like that, what's going to happen is at runtime, when the app is running, the app suddenly crashes. But Kotlin will not allow that because that value there is null. Kotlin will not overlook it. In development, it will flag it to tell you that, oh, you have a null value. So you need to do something about it. So basically,
Sirs, I can't hear you.
okay, can you hear me now?
Yeah.
Okay, 1 minute, please. Let me just give me a second.
Sirs, I can't see your screen.
Right? Can you hear me now?
Yes, I can.
Yes, we can hear you.
Okay. Actually, the meeting kind of closed on my end, so that's what happened. Okay. So, so having understood the language, I was speaking about non-safety basically. So the way non-safety work is that if a value is null for some programming languages, right? Usually old programming languages, I think Java now has non-safety. It was then that Java doesn't have non-safety. The way things work is that, excuse me, the way things work is that when, I'll be wrapping up shortly now, when you try to access a value that is null, null means there is no value to this, it is null, it doesn't have a value, right? It's existing, but it doesn't have a value. So when you try to access that particular variable or that particular thing, permit me to use thing now, something, that particular thing that doesn't have a value, if I try to access it at runtime when your code is running or when your program is running, if it's null, usually what happens is that the app crashes. The app crashes. When the app crashes, that's happening at runtime. As a developer, you don't want your user to come to your app and they click on something, your app is crashing. No, that's a worse user experience. Yes. Now, what Kotlin does is that at compile time, when your program is compiling in development, you can see it that, oh, this value, it will crash at that point in time. It won't compile. So at that point in time, you can see it and fix that issue. Probably you're using a statement to check that if these have a value, do this. If it doesn't have a value, then do something else. You have actually been able to catch the supposed events, and you're doing something about it. So that's one good property about Kotlin. Now, having learned Kotlin, the next thing you want to learn is you want to learn about Android operating system. I want to learn about the Android operating system. Somebody is saying, let's say I want to develop a mobile app for a bank and it's going to run on Android OS. How will a mobile dev typically work through it? So that's something that will become later, but when you want to develop a mobile app that works on Android alone, then probably you want to go for native Android. So the first thing, just like I say, is learn Kotlin. When you learn Kotlin, that's the language. It's just like I'm going to the Southeast, for instance, and I want to speak. I have to learn the language because I'll be using the language to do everything I want to do there. I hope that's clear. You'll be using that language to do everything. So the way it is that Southwest or Southeast, as the case may be, becomes my operating system. How do I speak to that operating system? I have to use Kotlin to speak to that operating system. Because it's Kotlin that will take my code and convert my code to machine languages that operating system can actually understand. I don't know if that's clear. So if you are working on Android alone, then definitely you're going for Kotlin, Android alone. Of course, you can do cross-platform and develop and compile for Android alone. You can do cross-platform as well. Compile for Android alone, and you're not compiling for it or building for iOS. I don't know if that's clear. Is that clear? The person that dropped the question, is it clear? Just give a reaction that the response is clear to you. So,
Yes.
okay, cool. So I'm going to be stopping here. While the next session, I want to apologize first for the lateness. I was actually somewhere and I had a delay. So that was basically why I could not start the class properly on time by 4 as opposed. Then that's why we had to start by 4:30. Apologies for that, please. So I think the next session, once I get a hold of the next session, there'll be proper this will start promptly by the time assigned. And by then I'll be sharing a slide and I'll be sharing some other resources on how to go about from native both ends, then also cross-platform as well. So I think I'm gonna stop here. If you have a question, please raise the question before the call it to wrap. Thank you.
Thank you very much, sir.
Yeah, thank you very much, sir. Maybe for our next class as well, maybe if it will be convenient for you, I think it will also help if we can